Okay, in 8.3 we talk about compound inequalities. This is where you combine two different inequalities with the connecting word of or and. Now, how do you tell the difference between or and answers? Well, you take each individual answer, and with or, you just draw both of them on the same number line. And whatever numbers you end up darkening in, so to speak, is your answer. Okay, so if they're two completely separate parts of the line, you're going to have to draw it this way, and you'll have two separate intervals notation with a union in between. That's not a capital U, that's a union symbol. Okay, and then the set builder notation is just each one with the or word connecting. Now, if they both happen to be greater than 1 and greater than 5, it tends to be the one that ends up covering more of the line. So this is simply just greater than 1. Even though you have greater than 5, when you start with greater than 1, you're including greater than 5. And then if they're both less than, again, the one that's larger here is the one that ends up being the one that you include. In this case, it's 5 or less, and minus infinity to 5 with a bracket there. Now, what does and look like? And is where they overlap, where if you draw them both on separate number lines, two separate number lines, and then you look at where the two overlap, and when you combine where they overlap, that's your answer. So if you think about greater than 1, so 1 to infinity, and then less than 5, 5 to minus infinity, well, they overlap between 1 and 5. Okay, and then greater than or equal to 1, that's bracket 1 to infinity, and then less than 5, that's parentheses 5 to minus infinity, and so they overlap here. And the common numbers there, they both have a 1, they both don't have a 5, so you can't include the 5. And then this one, less than 5 or equal to 5, and less than 1. Well, you can't include less than 5 because that's only part of one of the two inequalities, and it's got to be part of both of them. All right? The and, you can think of it as think about it as ladies' night at a bar when they say ladies get in for free. Well, to get into a bar you need to be 21, but to get into the bar free you have to be 21 and female. So if you're 21, you don't necessarily get in, but if you're 21 and male, you don't get in, but 21 and female, you do get in. So you have to satisfy both conditions. And so here it's less than 1, and it's also less than 5, and so less than 1 is your answer there. So simply draw three number lines and give your answer to the one on the first line, answer to the other one on the second one, and look where they overlap, and your third line will be your answer. All right. So example 1 gives you the connecting word of and. So you solve the first inequality and you solve the second inequality just like you normally would. And keep in mind when you're solving inequalities, you solve them like you would equations. The only difference is you're going to be, if you multiply or divide by a negative number, you flip the inequality sign. Everything else is the same. So divide by 2, you get your answer. Divide by 2, you get your answer. And then we're talking about greater than or equal to negative 33 halves and less than 5 halves, so it's all the numbers in between. And this one's an and as well, and when you solve it by subtracting 1, here you solve it by adding 1 and dividing by 2, you get these two answers here. So less than 8, but greater than 9 halves, so it's everything in between those two. And here's an and when you solve each one, you get greater than 2 and you get less than negative or greater than negative 4. So you got greater than negative 4 to infinity, and you got greater than 2 to infinity. So where do they both have numbers in common? Well, just 2 to infinity, because anything less than 2 is only included in this one, and it's not included in that one. So the numbers that they have in common are greater than 2. Okay? Now with the or, you just come up with your two answers, and you draw both of them on the same number line. So you solve the first one, you solve the second one, and you graph each one on the same number line. So less than 1, or less than negative 4, and 1 or larger. Then this one, same idea. You solve this one, solve that one, and you graph each one on the number line, and you get your answer. Notice you have to put that union in between the two. And when you type this in on your computer homework, you're going to have to look for the template onto the, typically it's on the right hand side. Click a template for set notation, and you should find a U and an upside down U, which is intersection, but you want the normal placed what it looks like a U, but that is not a capital U letter. It's a symbol, mathematical symbol. Alright, so this is an OR. Again, so you're going to say less than negative 3 and greater than negative 4. So greater than negative 4 and less than negative 3 includes everything on the entire number line. So it's all real numbers. Now what if you have what they call a triple inequality or a three-part inequality? Well, you've got three parts to it. You got the 1 less than x less than 5. And the x is always in the middle. Alright? So if you're going from 1 to 5 and you're not including 1 or 5, you got parentheses on either one. And if you go from 1 to 5 but you are including 1, you're putting a bracket at 1 but not at 5. And then here you're putting a bracket on the 5 but not the 1. And here you're putting a bracket on both ends. And this is how you write the interval notation and the set builder notation for that. Alright, now when you solve a triple inequality or three-part inequality, you focus on the center. The center will tell you what to do here. So if you want to get rid of this and leave t all by itself, you have to subtract 2. But if you subtract 2 from the middle, you got to subtract 2 from the left and the right. All three parts you have to do the same thing to each one. And when you do, you get t is between 2 and 6, not including 2, but it is including 6. Then here you divide by 3 everywhere because it's 3z, so divide by 3 to get z all by itself. That's what you got to do there. And now it's between minus 1 and 2, and it's including both endpoints. And now here, this one you want to get rid of the 2 here, so you multiply by 2. And then you want to subtract 1 to get rid of the positive 1. And then you got to divide by a negative 1 because you don't want negative m, you want m. So when you divide by negative 1, your inequalities flip. Less than becomes greater than, less than becomes greater than. Now, typically when you write a triple inequality like this, you want the smaller number on the left and the larger number on the right. So this, from here to here, is just a rewrite. This is just, instead of writing the 6 on the left and the minus 7 on the right, you're writing the minus 7 on the left and the 6 on the right. So the greater thans become less than. Don't confuse this with this. This here to here is you invoking the rule of dividing and multiplying by a negative number. Here to here is just a rewrite. Just like I said, you can think of an inequality as your teacher is older than you, or you are younger than your teacher. The relationship's the same. It just sounds different word-wise. So 6 is greater than m is greater than negative 7 is the same thing as negative 7 is less than m is less than 6. M is sandwiched between the two numbers, and m is sandwiched between the two numbers, and so you get your two answers right there. Example 4, we talk about the ground level temperature at 80 degrees. The temperature in the atmosphere, based on how many miles up above the atmosphere you are, which is x, this will be the temperature, 80 minus 19x. Now they want to know what ranges of mileage of altitude is between 23 degrees and 42 degrees based on this function here. So you plug in the function into the inequality, and there you go, you can solve that inequality. So this temperature model, this equation gives you, will give you between 23 and 42 if you solve it properly. So you subtract 80 from all three parts, and then you divide by negative 19 from all three parts, and you get this. And then you want to do the rewrite. And now you can say between altitudes of 2 to 3 miles, this is the temperature range you would expect above Earth. Right? Now the number of internet users in millions during year X can be modeled by the formula 11.6 parentheses x minus 2000 parentheses plus 124. Estimate the year when the number of users is expected to be between 240 and 275 million. Alright, so you've got this guy is your inequality, and you're going to sandwich it between two numbers. Now, they show you the numerical approach is where you just you let this guy be between 240 is less than or equal to 11.6 x minus 2000 plus 124 is less than or equal to 275. So you would subtract 124, you divide by 11.6, and you add 2000, and you get some answer, something between one and the other. Now they show you the graphing approach. The graphing approach is where you graph each one of these parts. You graph y equals 240, y equals 275, and y equals this guy. And when you do that, you get three different lines. These y equals this and this are just horizontal lines at 240 and 275. And this guy is a line. So now where they intersect is where they equal 240 or equal 275, and all the numbers in between are where it's in between those two numbers. So you can actually use your graph to figure out the answer. So the intersection here is 240 in the year 2010. And here is the intersection of 275 and the year 2013 approximately. So you can say that the answer should be between 2010 and 2013. And you look here, 2010 is 240, 2013 is 274.6, very close to 275. So you can look at a table even and tell that the answer should be 274, it should be 2010 to 2013. Alright, now this one, you take the inequality and you just write down your answer that way. Okay, there's nothing unusual there. X greater than 3, that's just from the previous section. Okay, now with the OR, we're going to take each answer, and they want us to write it in interval notation or set builder notation. And then this one, we're talking about greater than 3 and less than or equal to 3. So it's greater than 0, and it equals 3, but it's less than 3. So between 0 and 3, because you want to know what they have in common, where they overlap. And that's your set builder notation. Set builder notation is just you write down the inequality just the way they phrase it. And this one you want less than 1 or greater than 3. So you're talking about answers to both on the same number line. Right? So here are the similar questions, and these are the individual questions we will be doing. And again, this is in the order you'll see them on your computer homework. So the first one says write this with interval notation. So it's 2 to 4, 2 to 10 with brackets on both ends. And here it's 5 to 8 with a parentheses on the 5 and a bracket on the 8 because you don't have equality here and you do have equality there. Less than 4 is minus infinity to 4. Okay. Greater than negative 2, less than 5, it's got to satisfy both, so it's between minus 2 and 5. Again, you can draw three number lines. One that says minus 2 or greater, another second line says less than 5, and then you imagine you're putting the two lines on top of each other and ask where do they overlap, and they overlap here. Okay. Less than or equal to 8, greater than negative 8, so negative 8 to 8, but you're including 8 and you're not including negative 8. Less than 1 or greater than 5, greater than or equal to 5, so you're including both answers because OR takes the answers from both. Okay, and you solve this, you solve that, and you're looking at what they have in common, and you get this answer here. Or you solve this one, solve that one, and you come up with both answers. So less than negative 11/5, which is negative 2.2 to minus infinity, and greater than minus 1 to positive infinity. Okay, triple inequalities, focus on the center. You're going to get rid of the add 4 by subtracting 4 in all three parts. And there you go, there's your answer. And then here, divide by 3, because you got a 3x, so you divide by 3, and you get your answer. Okay, then here you subtract 1, and then you divide by 5, and there's your answer there. And here, you want to get n all by itself, so first subtract 4 from a positive 4, okay, and then divide by negative 1, and you get this guy here. And you got to do a rewrite, because you want the smaller number on the left, and there's your answer, and that's how you would write your answer there. Now here's where they ask you to solve it using a table. So you want to know where 2x minus 1, which is your y1 equals 2x minus 1. Where does 2x minus 1 equal negative 5? Well, it equals negative 5 right there at negative 2. And where does it equal positive 1? It equals it at 1. So from minus 2 to 1 is your answer. Okay? So minus 2 to 1 is your answer there. Now 85, they draw a line there and they say, where is this line, y1, in between minus 2 and 2? Well, here it's equal to minus 2, here it's equal to positive 2, so that's numbers from minus 3 to positive 1. So minus 3 to 1. Okay, and again this one, where do they intersect? At minus 2 and at 0. Remember, we're looking for x values, so between minus 2, actually it's less than minus 2 and it's greater than 0 because we're looking at less than -2. So where is this guy lower than that, and where is this guy higher than that? So you're actually looking at the. Sorry about that. You're actually looking at the outside numbers, not the inside numbers like you typically would. Alright, so this one shows the distance traveled in miles on a train from Seattle after X hours, from hours 0 to 5. And so they say, is the train moving towards or away from Seattle? Well, at time 0, it's 0 miles from Seattle, meaning it's in Seattle. At time 5 hours, it's 390 some miles from Seattle, so it's moving away from Seattle. Right? Times when the train is 150 miles from Seattle, it's at hour 2, and 300 miles from Seattle, it's at hour 4. So when is the train between 150 and 300 miles? Well, between hours 2 and 4. And when is the train's distance from Seattle less than or equal to 150? Well, it's from hours 0 to 2. Right. Example 9, they give you a formula for the dew point, x miles into the atmosphere, based on a ground temperature of 60 degrees. And they say find the altitudes at which the dew point ranges between these two numbers. So you sandwich that dew point between those two numbers. And we know the dew point equals 60 minus 5.8x, and so now you just solve that triple inequality. Subtract 60, divide by -5.8, and do a rewrite. And that's what your answer is, between a half a mile and 1.5 miles. Alright, same idea here. You're sandwiching it between 41.5 and 22.5, and you got the equation sandwiched in the middle, and you solve it like we did the previous ones, and then you have to do a rewrite, and you see it's between 1.5 and 2.5 miles above the atmosphere.